Hi, my name is Kelly Dunham, and I will be discussing two examples of heat transfer that use the processes of conduction, convection, and radiation. To understand these three processes, we first need to talk about thermal energy. According to the first law of thermodynamics, energy is neither created nor destroyed. The universe is considered an isolated system, and all the energy in the universe is conserved. Furthermore, when mechanical work is performed in an isolated system, some of that energy is transformed into heat, which is then lost to its surroundings. This transfer of heat is classified as thermal energy and is considered kinetic. There are three main forms of heat transfer: conduction, convection, and radiation. The first process I will discuss is conduction. Conduction is described as the molecular agitation within an object without movement. Thermal energy is transferred between molecules by movement. The movement is either vibrational or motional depending on the object's state of matter. As an object becomes hotter, the kinetic energy of the molecules will increase. This energy is then transferred to slower moving, cooler molecules, which will increase the kinetic energy and temperature, which will increase their kinetic energy and temperature as well. The second process to discuss is convection. Convection can only occur in a liquid or gas because its molecules must be able to move freely or flow. When a liquid or gas is heated, its individual molecules will become less dense. Less dense molecules will travel upward, while cooler molecules at the top will begin to sink. The cooler molecules will sink to the bottom, where they will be applied to heat. The warm and cooler molecules will travel up and down continuously in a current until heat is no longer transferred to the medium. This slide shows pictures of conduction and convection. To the left, the picture shows the moving currents of warm and cool liquid or gas molecules. To the right is a picture that shows how molecules use vibrational and motional movement with the three different states of matter: solid, liquid, and gas. The last process is radiation. Radiation is the transfer of thermal energy in the form of electromagnetic waves. It does not require a medium. Thermal energy is emitted from all wavelengths of the electromagnetic spectrum. The intensity and distribution of the energy waves is directly proportional to the temperature and composition of the source that emitted the radiation. A simple example that demonstrates all three heat transferring processes is boiling water in a pot on a stove. Heat is transferred from the stove to the pot using radiation. Electromagnetic waves from flames or a superheated coil will increase the kinetic energy of the metal atoms or molecules that make up the pot. The heat from the bottom of the pot will then transfer other cooler molecules in the pot using the process of conduction. Conduction is responsible for the introduction of plastic grips on the pots. Plastic is a poor conductor of heat because it has a higher heat capacity than metal, which will help the person not burn themselves while they're cooking. The thermal energy that was conducted from the pot will then boil the water inside using the process of convection. Warm water from the bottom of the pot will rise to the top because the water's density will decrease with increasing temperature. Cooler water will then sink to the bottom. This process will continue in a cyclical pattern as the temperature of the water increases. The internal energy of the water will increase until it reaches a phase change. The water will enter the vapor phase. This pattern will continue until either all the water enters the vapor phase or the heat source is removed. This is a simple picture showing all three processes from boiling water in a pot on a stove. My second example uses the sun, the land, and the sea, talking about sea breezes. In the morning, as the sun starts to shine on the land and the sea, it transfers heat with radiation. The rays of light emit electromagnetic waves in the infrared region to Earth. The thermal energy will travel through the gases of the atmosphere and strike the ground and the sea. Since the elements and compounds that compose the ground have a lower heat capacities than the water in the sea, the ground will become hotter faster. The water will not increase in temperature as rapidly because it requires more energy to raise its temperature by 1 degree Celsius. The ground will not absorb all the thermal energy supplied by the sun. Some of the energy will be deflected and will be absorbed by gases in the atmosphere. The gas molecules will absorb thermal energy and increase in temperature. As the temperature increases, the density of the gas molecules will decrease. The warmer gas molecules will travel upward, while cooler gas molecules will rush in from the sea. A cyclical pattern will continue as warm air travels upward and is replaced by cool sea breezes. It repeats until the sun goes down. After the sun goes down, the currents reverse because the water will be warmer than the ground at night. One example that actually uses conduction is asphalt. The material that makes up the land, such as asphalt, would use the processes of conduction to transfer thermal energy supplied by the sun. Certain parts of the asphalt that are directly in the sun will increase in temperature faster rather than others. The individual molecules that make up the hot areas of the asphalt will transfer heat energy to slower vibrating molecules. Hotter, faster moving molecules will transfer energy to the slower, cooler molecules. This is the end of my presentation. Below are my references for my in-text citations and my photos. Thank you very much.